Okay, let's continue section homework for the section 6.4, question 79. Okay, domain of the function f is all real numbers such that x must be positive. Remember the expression 2x greater than 0 divided by 2, xx greater than 0. Okay, now this is the domain. The graph of the basic logarithm function is, we have, remember, the point 1,0, and we have also the vertical axis. Approximately, this is the graph that corresponds with logarithm function, logarithm of the x, the basic. And now the first transformation is logarithm, the transformation logarithm x to the transformation logarithm 2x. It's obvious in this case is when you multiply by 2 inside occur the horizontal compress. At this point would be then half 0. Okay, now this is the compress. The asymptote is still the same, a little bit compressed. Logarithm 2x. And also multiplication by half. When you multiply this time 1/2, logarithm 2x, in this case occur the vertical compress. Because you, for example, this stays the same, however divided by 2, everything's at any point divided by 2 is here. This is like and this point stays the same, of course, because it's 0. So 0 divided by 2 is 0, but this point divided by 2 is, so occur this transformation. This is 1/2 logarithm of 2x. Look in this graph. Okay, let me use another color, always magenta for the direct function. Okay, look at the graph. The range of the function f is all real number. Now let's find the inverse. The inverse is, the original function is y is equal 1/2 logarithm of 2x. Now remember, for finding the inverse you interchange x and y. It's 1/2 logarithm of 2y, and so for y. Multiplication by 2, whole thing. Now compute the exponential, both sides. This is 10. 2x is equal, cancel out this part, is 2y. Now divided by 2. Divided by 2 both sides is 10 2x raised to 2x over 2. This is the inverse function. It's exponential with the base 2. One typical point here is, okay, we suppose this point is 1/2. So when you're switching, this is 0,5. 0,5 is, suppose it's 1 here, 0,5 is this. And this is the line Suppose 1 1 1 1 is here, 1 half. This is the identity line, and the other line, using the color blue, is supposed like that. So we have obviously the horizontal axis at 2 is symmetric about the line identity. They look like that. This is the graphic. It corresponds with the inverse function that is 10 2x over 2. Okay, the inverse. Now finally, the main of the inverse. It's obvious it's a real number, it's exponential, and also it's exactly the same the range of the direct, and the range of the inverse is only y such that y is greater than 0, because it's exponential and the positive part only, and they correspond exactly the same with the domain for the original. Okay, we continue the homework for the section 6.4. Now equation 81. Okay, domain of function f is equal or real number such that x is greater than or equal, this is the restriction, is x plus 2 greater than 0, x is greater than negative 2 minus 2. This is the domain. Okay, now the graph. The graph look like that. This is, I suppose, is the logarithmic function. This is the point 1,0. This is the vertical asymptote, x equals 0. It's on the y-axis. Now, this is approximately, the base is 3, so it's easy to see. Is, for example, logarithm of 3 is 1, is 2, 3 is 1 here. So at least we have one more clue. It look like that. This is logarithm base 3 of x. Now this point is a point 3,1. Now the transformation number 1 is logarithm base 3 of x transformed to logarithm base 3 of x plus 2. Entonces es obvio que es the horizontal shift 2 units left. Okay, so now change the vertical asymptote is here, now change to negative 2. Here negative 2, this is my new asymptote, and this point is moving 2, is 1, 2 here, now it's negative 1, 0, and this point is 3 minus 2 is 1,1. Okay, and this is the graph of the new transformation. Is logarithm base 3x plus 2. Now plus 3. Plus 3, when you add plus 3 is plus 3, because the last transformation is logarithm base 3 x plus 2 plus 3. It's obvious it's vertical shift 3 units over. Okay, both the vertical asymptote stay the same. So this point is negative 1,0 become negative 1,3. 1, 2, 3 here. This point is a point negative 1,3. And one more point, this is 1,1. So you move 3 is 1,4. 1, 2, 3, 4 here. Okay, let me use a magenta color and a little bit more bold the trace. Okay, no, magenta. Okay, this is this. This is this. Look in this. Look in the graph. It's obvious that the range of the original function f is equal or real number. Okay, let's find the inverse. The inverse, as always, you put y equal 3 plus logarithm base 3 of x plus 2. Interchange x and y. And solve for y. I move 3, x minus 3 is equal to logarithm base 3, y plus 2. Now, raise to the 3 base, this is 3, x minus 3. This cancel out, is equal to y plus 2. Therefore, the new y, que es the inverse function, is equal 3 x minus 3 minus 2. And this is expression, this is exponential. Okay, let me try to do the graph, but I'm not using transformation, no using this point, the reference point and the line que represent identity. I'm using is symmetry. This is the line y equal x. And for example, let me use a color blue. This point is negative 1,3 is 3, negative 1. 3, negative 1 is here. Approximately 3, negative 1. Okay, so this is another common point. And this is another common point. And this is the inverse function. And the expression for the inverse function is 3 x minus 3 minus 2. It's exponential base 3 x minus 3 minus 2. Es obvio que we have one horizontal axis here in negative 2. Negative 2 is here. Y is equal, negative 2 is horizontal axis. Now the conclusion, domain of the inverse function is equal or real number. Again, it's exponential, and you see here is equal the range of the original, and the range of the inverse function is only the value of the y above the horizontal axis. So is y such that y is greater than 2, and this corresponds exactly the same. This, but I change of course x for y because it's the range.